Okay, welcome to today's Space News webinar, which is about geospatial intelligence and data labeling for AI. But really, we're going to just get into a lot of what's hidden in that data and the sort of coming AI revolution in geospatial intelligence. Joining me well, there's four of us today, including myself. John Isaac Clark, who's Vice President, Head of Insights and Analytics at Maxar. Gary Dunlow, Vice President at USGIF, and David Gauthier, who's Chief Strategy Officer at GXO Incorporated. The way this is going to work is, per usual, if you're familiar with these, we're going to chat for about 45 minutes. It'll be sort of this interactive conversation, but we do want to get you involved in this. So if you have questions, make sure to put them in the chat. One of my colleagues will be compiling these and sending them to me. So don't wait till the end to put your questions in. You can just put these on in an ongoing basis. You know, if we've already addressed that during the conversation, we might skip over that, but maybe there's a different way that you asked it that kind of lends new insights. So the last 15 minutes of this conversation is going to be that Q&A, and I will try to get through as many of them as possible. But that's essentially it. This hour goes by pretty quickly. So let's just, cut with the introductions and just like get right to it. I want to sort of set the stage a little bit in terms of what we're talking about. And David, I really was hoping you can kind of give us sort of that bedrock to kind of be as sort of a launching pad for these broader conversations. But what exactly does geospatial intelligence encompass? What is data labeling? And how is it now sort of used and increasingly used in the sort of modern context, not only in things like defense, but environmental monitoring, disaster management, and just sort of these broader pattern recognitions that are valuable at both the public and the private sector. So Dave, if you want to kind of give us sort of a basics of what we're about to discuss, that would be really helpful.
Wow. Thank you, David. Yeah, absolutely. So, just thinking in terms of geospatial intelligence writ large, in a simple way, it's about um, measuring and understanding the physical properties of the Earth and all of the human activity and processes that happen on it and about it in the domains of, land, sea, air, space. And I should say undersea as well, right? The newer definitions of geospatial intelligence talk about going from seabed to space. And so doing that has historically been done with information collected by people and then also from airplane and satellite imagery. And you collect enough images over time, you can sort of map out the entire Earth and understand key activities going on in those locations. It's definitely it has been in a human intensive work process. And, similarly, neural networks and machine learning have grown up over time, over decades. And it wasn't until I say the mid 2010s that some of the machine learning capabilities really came to the forefront for image object recognition. This idea that you could feed a machine learning network a lot of imagery, label all the objects that are of interest to you in that imagery, train it over time and improve its performance. And so we thought in around 2015 timeframe, this would be perfect for satellite imagery. And it turned out it was less than perfect at the time because most of the imagery on the internet was a perspective like you're seeing today, right? Human faces in a frame from a same perspective, cats, dogs, other objects, but not a lot of variability to what you're looking at.
Yeah.
And when NGA tried to apply this to satellite imagery, the perspectives were all different. The shadows were changing, the lighting conditions, clouds got in the way. Geometries were always unique, and it was very difficult to train these capabilities. Nevertheless, the DoD and NGA sought out, a sort of a major program for this, which we all know is MAVEN, and it worked on a lot of airborne imagery, and it transitioned to NGA to continue working with satellite imagery today. This is incredibly important for the business of geospatial intelligence because of the sheer volume that we're dealing with now with Earth observing systems. If you
Right.
look at, Maxar collecting high-res imagery, maybe 5 million square kilometers per day. I'm sure JC will get into that. And then,
Well,
I've checked.
let's get
Yeah,
into that system now.
and
So
NASA has an Earth observing system that's petabytes per year. So I mean, it's huge amount of data. So we can't do this with people alone, and
yeah.
that's the problem before us. Yeah.
Well, so this is a space news forum. So part of the impetus is obviously news, right? So part of the hook of this panel was that $700 million commitment from the National Geospatial-Intelligence Agency. This is, surrounding data labeling services really over the next 5 years. And I think this is the biggest contract ever for data labeling, if I'm not mistaken. And I kind of want to get into why this investment is so significant. Gary, I'm gonna go to you on this one, and maybe you can take this from a national security perspective, because it does seem like there's this confluence of technologies that are coming to bear, moving at a speed that we haven't seen before. But from a national security perspective, and from just sort of the broader construct of a commitment to data labeling and geospatial intelligence, it seems like we're at the vanguard now of kind of a different era.
Yeah, thanks, David. It is an interesting time, and I do think it is the largest contract specifically for data labeling, and that's a major statement, I think. And I think a long overdue recognition of the amount of resources that are required to do this work to make AI and ML computer vision a reality. Dave talked about some of the experiences in the past. We both were at NGA for many years, and I'd say this all started more than 20 years ago when the agency started to, because of the counterterrorism fight and the recognition of structured data's ability to increase our insights into what terrorists were doing and where, that led to better decisions, faster decisions. That drove, and it was the impetus for something called object-based production, which was driven by DNI Clapper's desire to get data portable and structured so it could be used across the community and improve national security and intelligence operations. So I think the reason this is so important is right now we still have a lot of seams between the agencies when it comes to data, partly because of security reasons, partly because of cultural reasons, partly because of technical and technological reasons.
Yeah.
And so a lot of that can be broken down by having standard data label processes and creating the data labels and allowing the data to be used in different ways. So, like I said, I think this is just a long overdue recognition by their resource providers that it requires a lot of manual work to make the AI ML capabilities real.
Yeah. Now, it's sort of leaping off to that. We've got this high point over here, the news peg, why we're focusing on this. JC, you're the sort of the representative here of the sole commercial entity that's on this call here. You're going to be sort of making use of a lot of this. I wonder if you can get into some of the nature of not only sort of the hidden potential in all of this, not only in terms of just the application of AI and machine learning and data labeling, but just the scope of how much is coming down from space, just to the unprecedented nature of data that is coming down that seems only to be going up, and how this has sort of evolved over time. In our previous conversation, you mentioned sort of the eye loops process of how this process used to work, and sort of that the heavy human reliance, and where it's going now.
Yeah, absolutely. Thanks so much. I think, an interesting statistic that I uncovered as I rejoined Maxar. I spent time in the business with Digital Globe from 2015 to 2018. Now back, almost a decade later, In the last decade, there's been about a 90x reduction in launch cost. So the price to put a kilogram in orbit has gone down drastically. That's resulted in about a 1,200% increase in things on orbit from 10 years ago. And I think at last estimate, around 1.8 petabytes of daily sensor data collected over what's happening on the surface of the planet. And if you go back to what I'm sure some of the folks who spent time at NGA would know, the light table, which is where an analyst is looking at an image on a light table to try to understand digital film, like what's happening in the image, to 1.9 petabytes of data coming down over the surface of the planet daily. Certainly light tables aren't going to work anymore and haven't in a number of years. But what this really represents is, how do we take this preponderance of data coming, of course, from folks like Maxar, but now many others, some of which we're proud to partner with, but some the U.S. government and other governments have their own sensors that isn't even included in that 1.9 petabytes of data, that is also coming down. And how do we start to unlock those features of human activity, of infrastructure change, and I think environmental, you pointed out disaster relief as well, coastal erosion, climate change, all of these factors in a way that we can begin to understand at scale as humans. And for years in both the geospatial industry and in the both federal civilian and defense sectors, you've had either geospatial analysts or intelligence analysts pouring through these images, drawing lines over roads or highlighting, military vehicles, et cetera. I think the really exciting thing for me is that there's a big investment in, as David pointed out, trying to begin capturing all the different ways these types of things we all care about are aggregated for training data. And from an AI and ML perspective, that means if you can feed a model hundreds of examples or thousands of examples of individual features, then you may have the opportunity across different sensors, across different ways it may show up, to more accurately, automatically characterize that thing and then keep track of it over time, or they're more or less. And so I think this automation element is an important step for both. There's way more data coming from space than ever before, and there's more coming. But how do we make sense of it and interact with it? And how does machine learning utilize that? There's a saying, it's the training data. There's a follow-on to that, which I won't say. But that's really, AI is data. And so this is the first step towards really enabling much broader use of that through I see this program.
See, now it's the automation aspect of this, particularly when it comes to defense, which I want to get to in sort of a bigger way, or maybe we'll get to that right now, since we sort of, you mentioned in terms of threat analysis. I think that is the thing that maybe gets some people a little bit queasy in terms of the framing of this, perhaps, because I mean, Gary, you and I talked about sort of the difference between pattern recognition as a defense mechanism, or pattern recognition as a response or offensive capabilities, which are like two wildly different worlds, I would think, or at least the risk analysis that's sort of imbibed in that would be. I wonder if you could kind of address that, not only in the context of just the broader threat scope, but the speed by which leaders at the national level and elsewhere kind of have to respond to these things vis-a-vis, shifting geopolitical risk patterns, hypersonic weaponry, all of these things kind of reflect a period in time in which we just have to make decisions that are potentially life and death in a much shorter scope. So where does this fall into that whole?
Yeah, I think it's a good point. And I think what's important to me is that we understand this is a multivariate problem, right? We like to distill things down into binary, and in this case, it's not that easy. And I know there are a lot of conversations about, in fact, I've heard up on the Hill, some of our congressional leaders getting frustrated that everything hasn't been automated already. So there's kind of a lack of understanding, I think, at the most senior levels of what it requires to make the AI ML work, and what missions it should be applied against, right? Because you have to deal with the ability to trust the model, trust the data, trust the algorithm, That's a lot of links in the chain to trust when you're looking at a decision at the end. And I don't know that our adversaries will follow the same sort of ethics and moral standards that we'll follow in each of those areas. But I do think this is worthy of a serious conversation about which missions this should be applied against and which missions it may never be applied against. And so I think initially the toe dip in the water was environmental issues. Dave Gauthier here led the way on that at NGA, and how can we use some of these models and AI to determine some pretty simple but low risk answers to some intelligence issues. I do think there are ways to apply this that are necessary today to help the analysts do their job faster. So things like searching for unknown things that what that thing you're looking for looks like, but you don't know where it is, right? That takes a lot of time off the analyst plate to do other things. But then there are some very high risk decisions. You mentioned hypersonics, right? Not something we want to get wrong. So maybe from a GeoInt perspective, maybe too risky right now. I'd put it on the same level of
But
targeting
there's a time
right now.
question with that one. I think that's where I worry about, because it's too
Right.
risky, and yet the response time is so much shorter than it used to be.
Yep, and I agree, and that's where we need to bring in multiple sources of data. So, I heard a senior leader this last year talk about how um, they want to automate everything because they used to work on a system called DSP that gave a specific signal, and you could tell exactly what something was, and you could act quickly on it. That is true, but that doesn't apply to everything. And you also need to think about, is it a defensive result that you're going to create through that decision process, or an offensive result, and what are the impacts? So I
David,
just think it's really complex.
David, I want to jump into sort of some of the non-defense and non-intelligence, at least at the national level intelligence sort of potential applications, things like port activity and environmental aspects. But since Gary mentioned this, um, in terms of adversaries and in terms of different rules of the road that are part of the operating procedures, let's say out of Europe, more notably out of China, and even at a commercial level, in terms of sort of just before sort of this sense of regulations and accountability and transparency has been codified in a sort of a more meaningful way. Where do you sort of see the rub here in terms of like how we collectively move forward in a responsible manner without sort of ceding the competitive edge in terms of like pushing this technology at the pace that our adversaries are pushing it?
Well, yeah, it's a good question. And I think Gary said it well when he talked about it's a multivariate problem. And there's certainly a fitness for use with different AI solutions against different missions, whether they be defensive or offensive, on the military side, or whether they be environmental or otherwise, where there's sort of less risk in terms of the government calculus and who's responsible. I do think the technology will become so pervasive and so helpful across so many sectors that it will be created, and it'll be incumbent upon the government to understand the responsible use of the technology and
Yeah.
apply it to the missions as necessary. You
Can they
you
keep
bring
can they
up,
keep pace with it though? I think maybe
and they
that's the
keep
question.
pace with
Can
it,
they keep
right?
pace?
So I think there's my personal bias is that the technology will save us so much time and give us the opportunity, even in that hypersonic example,
Right.
to respond in time, so that there's not some kind of disaster. That you have to enable the technology to be there, um, and also enable the human decision making to be there at the right time in the right place. So if there's no other alternative and you have to trust an algorithm and the stakes are high, that's a great decision for a human to make at the very last minute. If
Actually, that's a great point that I want to take to JC, because this is, I mean, you're the commercial entity here. I wonder if you can talk about that sort of the blend of data labeling, growing reliance on machine learning and AI, but how that sort of blends into more traditional approaches, the human experience, human backups. Will there always be a need for human oversight? And like, what is the role of a commercial technology company in this sort of emerging ecosystem?
Yeah, I think it's a great question. I think, as I think the largest commercial entity providing this type of content, we've amassed over 125 petabytes of content of the surface of the planet from our own constellations alone. And I think that, intrinsically, because AI is data, it's just a different representation of data and a different kind of multidimensional graph, or just depending on the model framework. Our view is that locked inside, and I presume NGA and others feel the same way, locked inside this representation of data, in this case images, is knowledge and information and patterns and trends that to a human decision maker may take years to understand and learn. And I think where I'm focusing, and I think we have a role as an organization in the industry, is the enablement of both our own machine learning and AI approaches to begin to unlock that, but also partnership with leading organizations who are beginning to put billions of dollars towards unlocking this. I think there's an interesting question though about like then how you present this to a user. And I believe it was Gary's comment, kind of about multivariate problem. If you could represent years of, let's say, let's not use a military use case, let's say human economic development, and what typically occurs as human
Or
economic
activity or
development is
something
occurring,
like
or
that sort of thing.
activity,
Yeah.
you could potentially feed that into a model which would understand this is beginning to look like a pattern. So likely humans are, let's say, developing parts of Africa because China's investing in more mining or infrastructure or whatever the case may be, and understand that and be able to how would you even present that potential pattern match to a human? And I think that
Let me stop you there because I want to
Sure.
parse that point real quick, because
Yeah.
potential pattern recognition is really kind of an interesting phenomenon when it comes to sort of the ethical considerations with all this. So how do you safeguard and you create sort of these safeguards in which you're dealing with, especially in those sort of nascent stage data sets that you're relying on to avoid against bias or groups that are maybe unfairly represented when you have maybe incomplete data sets and yet are still relying on them for at least advising policy prescriptions or commercial activity.
I don't know if you want me to respond to that one, but I think the short answer, it's in the training data, and I'd love to hear Gary and David's opinions there as well, because again, AI is just data. It's just a representation. And so what you would correlate to those objects, let's say you have roads appear, you have buildings appear, and they happen to be factories. It's somewhat of a subjective that equivocates to humans are investing, but that doesn't take into account whether the humans owned the land to begin with, or what was there before and what was it used. Those are interpretations. And so I think it becomes interesting. I would hope for a world where, kind of the multi-perspective of what that means would come from not just a single viewpoint, but potentially many. I do think the opportunity with NGA's activity is to just build the building blocks of this is a thing, this is a road, these are these labels, this labeled information, but there's certainly like another layer of who owns it, whose land is it, what is its purpose, is its purpose positive or negative, which really then speaks to interpretation. That is an interesting. I'd love to hear other comments from the group on that, but that's my
Yeah.
perspective.
Yeah, Gary, let's go to you. I want to get actually both your perspectives on this very same question. But as JC mentioned, AI systems are only as good as the data that they're trained on, right? And
Right.
there's I mean, there's concerns about the nature of how it might be applied, particularly in the commercial space. The concerns about invasion of privacy or surveilling maybe private spaces, quote unquote. So how do we start to develop these things? I mean, and your focus is more on the national security side, but I think it's applicable there too. How do you make sure these molecules are sort of developed not only ethically but accurately?
This is again where I think there's some myth out there about AI, right? That you just train the model and then you throw it over the fence and you're done, and
Fair enough.
it provides all the right answers, right? And that's just not true. You constantly have to be training the model with updated data. You constantly have to be refining the model, and I think the model will spit out an observation or an assessment, but it's just another data point, right? A human needs to make the decision based on what that human knows and understands. And that speaks to needing to understand the model and the data set that they're being that's being used to provide them that other data point, right? And then they provide their own context and make a decision. So it's a little bit of a fallacy that AI is just going to be spitting out decision points for decision makers, and that they don't need to think themselves at the end of the process.
It's certainly not a sort of easy bake oven type of situation where you sort of set it and forget it, right? But for those who remember that or have kids, um, I think the same question to you, David. But I if you can kind of also incorporate this question of speed, and I want to kind of keep coming back to this because on the one hand, when we talk about not only sort of the threat landscape, but commercial opportunities, speed is becoming increasingly more paramount, especially as certain new technologies come online. Quantum, I imagine, is going to redefine this game altogether. Um, but also just like the nature of human operators feeling maybe a little bit overwhelmed by how much now is coming down and the possibility of missing things like you saw with buildup of troops on Russia's border. So even at the highest levels in organizations that you would think would be just on it, there are things that are missed. And so, how do you thread that needle, so to speak?
Yeah, there's absolutely too much information being thrown at the analyst or the decision maker, and an ever increasing need to go fast with the decisions that are being made. In the military parlance, they talk a lot about the OODA loop, where a commander will have to observe, orient, decide, and act, and run that loop faster than their adversary in order to have an advantage. Well, think of all the observation data we have now. How quickly can we orient that data so someone can make a decision and act on it? The orientation, I think, is the data preparation. That's the blockage right now. With all this information we're observing, how do we prepare that data and then use AI to help orient the decision maker to what's the most likely set of outcomes that their decisions can have? And it was well said by JC before about this building blocks approach. When it comes to GeoInt, you have to get the basics right first. You have to understand, what are these features? What are these objects? What are these basic activities? And then another layer of AI model can come in and say, when you see these objects together and they act a certain way, we might call that, a transshipment activity. Or if you see these other things happening together, that may be, a narco trafficking at an airstrip or something. And so you start building up these little scenarios, and the algorithms will eventually learn to be good, and we can have confidence in them that they're identifying these things. And then another layer can be trained on top of that to get even better. And the faster we can understand what is happening in the world, the faster the decision makers can respond to it, and that's how we maintain that decision advantage.
JC, I wonder if you could kind of jump off that and talk about some of the expanded commercial opportunities that you might see. You and I've discussed port activity, certainly environmental considerations, sort of outside the defense space and intelligence space, but then also let's talk about like where this is heading and where Maxar is sort of positioned. Because we talked about this sort of AI revolution that's taking shape in all sectors, really. But certainly in geospatial intelligence and kind of how that's applied both in defense spaces and commercial spaces, and where this really is heading, and maybe let's say a timetable of the next 5 years.
Yeah, happy to, though I would think my panelists would echo, I don't think any of us know where we're going to land in 5 years at the rate that things are going. I'm
Fair enough.
pretty sure we can be confident, though, of two things. it won't be as far as we all hope, but it will probably look way different than we thought. I would though answer that by pointing an anecdote. When I originally left Maxar in 2018, I was CEO of an AI company that focused on property intelligence for lenders and insurers. And so to speak to commercial use cases, here's again, and I think David said it, people would observe, surveyors would observe with a stake before there were planes and satellites and other things to understand where things are. And ironically, the insurance industry still implements that approaches many times where they would look at and physically inspect a property. What's there? How many buildings? What's its condition, et cetera. And the opportunity was to apply satellite imagery and aerial imagery together to enable insurers and lenders to understand exactly what's on the property, what's its condition, how's it changing, similarly to how NGA Intel analysts may look at, let's say, a garrison overseas. I worked with hedge funds on how do we understand where movement of goods are coming and what stockpiles exist that may not be on the market. And so I think that as the machine learning building blocks emerge to accurately assess an aluminum stockpile or the quality and condition of a roof on a home, and then the availability of data increases, so you can do that more and more frequently, you enable what I was able to enable before I came back to Maxar, which was being able to look at every property every year instead of 1% of your properties, maybe every other year, so that you can make more informed decisions. And I think that what we'll see with machine learning models, though, is not the ability to generate the quality and condition of a structure or the amount of thing in a stockpile, but more what does that mean when I can do that everywhere all the time at scale, right? How do I make sense of that? And one thing I saw in that industry was there was a movement. Wouldn't it be great if we could understand all those things, not for just 1% of our properties, but for all of them to, oh gosh, we've done this for all of them, and now we're doing it quarterly. How do we keep track of the data information? Where should we focus? What do we do next? And I do think it's that kind of more into the multimodal large language model space versus just a traditional convolutional neural net object detector, which is really where the future is going. And the things that it will unlock are understanding that activity at scale, what it means, what it relates to, and potentially recommendation on what should I do? What do I do with this information? I'd love my panelists' thoughts as well, but I think that's kind of where we go beyond detect to understand and potentially act. Which I'm glad was stated because it sounds like someone is reading my board slides. I hope my board watches this when we talk about OODA loops, because it's that process, right? It just gets quicker and quicker and quicker.
I think that's a perfect place to go to you, Gary, on this. Actually, I want to talk to both of you about this, but the everywhere all the time at scale and a faster capacity, particularly from the national security landscape, is a real question mark, not only from state actors, but you have just so many non-state actors that are maybe tangentially connected to governments in, say, in Moscow or the Kremlin, or excuse me, in Beijing, and it's not as clear anymore, and also just the nature of satellites being connected to the internet in a way. I mean, if you're connected, then there is a threat possibility there. So, how do you sort of think about this in terms of having that sort of human still in the loop, particularly as quantum starts to come on and become more part of our lives? I mean, Boeing is already ground testing quantum powered satellites, so it's just it almost strikes me as that it might be an impossibility at some point to have the kind of human interaction that we need. I mean, decision makers, at least for the foreseeable future, will still be at the top in a sort of managerial role, but I mean, you see where I'm going with this, right? It's a question of speed. I keep going back to, and I don't mean to be a broken record on this, but scope and
No.
speed are big question marks in this new landscape.
Yeah, I couldn't agree with you more. And speed is really the crux of the issue when you want to talk about competitive advantage. And all of us have touched on it during our discussion here today. I think so. This contract that NGA led is a step in the right direction in getting at the scope that's necessary. I think one of the things I'd like to say in context of this question, but also your question to JC about where it's going in 5 years is, and I don't have a crystal ball, so JC's caveats apply here too. I think where things will end up going is humans will not be able to look at every image anymore. Right now, that's how they're trained, and that's how they've been trained for decades. And it's hard for them to move away from that and trust an algorithm to say this is a T-72 tank or this is a hypersonic Clyde missile, right? And so that's gradually going to shift. I think we need to move away from the coin of the realm being imagery to the coin of the realm being the insights that are provided by different sources, including imagery, right? And so right now, a lot of budgets are geared towards the source data. That's just a step in the process. What we really need to get is those outputs, those insights. And I think we're going to have to train analysts and decision makers and policymakers in a very different way to allow them to trust a piece of information that they haven't seen where it's come from, but they've seen how the process works and how the process has been validated, and that the provenance on the data has been determined, and they can make a decision based on that. So
I think that's the question. David, I want to go to in one second, but Gary, I want you to sort of put a loop on or a button on this last point, is that as the speed increases, as the scale increases, as policymakers become sort of more comfortable perhaps with just sort of trusting the technology, and obviously through iterations of constant testing. So there's no sense of, just forgetting this and then
right.
coming back to it. But it strikes me, and maybe I'm wrong on this, but it strikes me that when we talk about the war theater, that we're going to be talking about responses as well, not just defensive analysis and
Mhm.
the nature of autonomous warfare and what that means, particularly up in the cosmos, but also down here in the terrestrial scape. What are the conversations that are driving that? Because I think that is the thing that people sort of wonder about in terms of where this is going.
Yeah. So by nature, my opinion, the government and the intelligence community and the NatSec environment is very risk averse, right? Because it's just you get bad headlines if you get it wrong, and people die if you get it wrong, right? And people in that work environment really care about making sure they get it right. And so what we do by nature is we dip our toe in the water and we try some very low risk approaches to these technologies, and it takes a long time to get to the point where we're able to apply them against high risk capabilities. So I just wonder sometimes when I reflect back on my career, should I flip that on its head? Should we be testing this on more high risk missions
Mm.
that then as a byproduct you get the capabilities against those low risk missions? So do we kind of have it backwards? And I think there are some places where they are testing it in high risk. So 18th Airborne Corps, through their Scarlet Dragon exercises, right, they've been doing some really interesting stuff that would be against some high risk missions, in targeting and making targeting decisions. So I think we just need to look at, is that approach maybe more appropriate in driving faster results? Going back to your speed question, right? Faster results that lead to faster decision making in the long run.
I promise I won't ask the speed question anymore. I think I beat that horse to death at this point. David, same question to you. Where's this heading? 5 years, 10 years?
Oh, 5 years out. Yeah, let's think about how much large language models have upended our world in just the last year or so. People think of them as a panacea. They're not a panacea, right? They do their thing, their trick very well. But what's been interesting to me is there are now companies using the combination of large language models with geospatial data. And so the ability to use natural language as an analyst or a decision maker and say, look, I want to know when X activity occurs within 50 kilometers of the border of Taiwan. Just tell me when that happens. A large language model can now parse that into a
Mm.
geospatial query and get in and set up that sort of alert scenario for you. That's a really valuable way to shortcut the process. What used to take somebody coding, a GIS system, it can now be done just by asking it. So that combination is already being demonstrated, and I think that's very interesting. NGA and their new chief AI officer, Mark Munsell, I think he's been talking about creating a new type of model, a large geospatial model that would have some understanding of the physical features, which is not present in a large language model. That is another good, forward progress towards understanding the world. And then World Labs, the new company with Fifi Lee, they're talking about large world models. So this is the idea that you can connect all of these things, our language, our physical world, and create models that understand in much greater detail what's happening. And I think that in 5 years we'll have the ability to ask questions that we never could get answers to before.
It's also just where the technology is going. I do wonder
Mhm.
where the sort of the brain computer interfaces and places like Neuralink are kind of play into all this factor, but maybe that's a different conversation altogether. JC, you're you know you're the commercial guy on this on this call, right? Um, what and I think that this is a question that I kind of get a lot. What do I need to know in terms of like if I'm a sort of a young professional now, or I'm a student, or I'm just sort of like coming up in the world, and I see this incredible pace of technological innovation and change and dynamic paradigm shifts that seems to happen at a cadence that, I mean, you can't even get a degree in the time of the whole thing has shifted. Maybe that's an overstatement, but it does seem like the timetables are speeding up. I just wonder, if for new professionals, like how they can kind of prepare for this upcoming AI-driven transformation.
I'm not sure if you asked me this because I have both a son in college and a son in high school, and I think about this often. I try to like think about what they're going, but I'm reminded of a quote and then a follow on that. Arthur C. Clarke said, "Any technology sufficiently advanced is indistinguishable from magic." But I find John Isaac Clarke saying, our view as a society now is that any technology sufficiently advanced is indistinguishable as technology. Like we just accept that these things happen and they're changing really, really fast. Where if 100 years ago we would have thought they were the dark arts, right? Um, and so I do think, we are accepting this rate of change in our daily lives. My Apple device now has Apple Intelligence on it, which is somewhat tied to ChatGPT and OpenAI and others. And I think the rate with which we're going to be exposed to tools, things we can utilize, and honestly, don't hate me, but I think it does go back to speed, right? The speed with which we can understand
Yeah,
information, that we can aggregate and make decisions, that we can
gonna have to rename
synthesize.
the webinar here. Yeah.
Right, yeah, hard concepts. I think that being able to ask questions of things is going to be more and more important. Not that large language models will be the only way we interact with machine learning, but being able to say, I want to understand a concept to a llama or a Claude or a ChatGPT helps me understand it more quickly, but then saying I would like to see an example of code that could now implement that thing is another way that, like, again, we're kind of asking questions or trying to define what we want, which I think is really, really interesting. I'm very curious to see what the group feels about the new types of interfaces. I did see a really cool example at Dan Poloni at Element 84 show me, David, that hey, I want an AOI around the Taiwanese border. It was really cool. Then how does that connect to, like, what are the sensors that are available to, like, get that information for me, and which are the most optimal ones to tell the types of activity I want? And then can you go actually talk to those tasking APIs and orchestrate that for me?
Hmm.
Is the type of thing that I'm passionate about building here at Maxar, and building it as a community, not just a commercial entity, because it's not just going to be our data and our sensors. It's going to be the communities bringing it together that will help answer that question most effectively, or you've just got one soda shot view instead of a holistic one.
Gary and David, they're good questions to toss both of you in terms of, JC took it farther than the initial scope, but that initial question of sort of like, how do you prepare if you're just coming into the workforce, or if you're just going to school? I mean, what do you look for in this transformation?
Yeah.
Gary, up to you.
So I want to jump on JC's last point about the community. So I spent a lot of my time in government trying to drive interoperability and the capability for us to work with our partners and with industry better. And so that speaks to what I talked about in my first answer about standards. And so I think one of the most important roles that NGA has for this community is establishing the standards for data labeling, for schemas, for interoperability. And so I'm hopeful that this contract helps drive some of that because uh, I'm gonna talk about the speed thing, right? In the Russia example, you talked about. I would recharacterize that event differently than how you described it. Our folks at NGA were all over that, and they knew what was happening. The challenge was getting other people to understand that and accept it, because they didn't have the same context, they didn't have the same data, they didn't have the same experience, right? And so by using standards and making sure the same piece of data means the same thing, whether it's to a German or an Australian or a Japanese partner, or whether it's to Maxar or Planet or Umbra or one of our other partners, and that their data means the same thing to us, that's what's going to drive that speed of decision making that you're talking about, right? Because you can't use one set of data because that data meets the standard. You have to have all sets of data meet the standard, the basic standard. There is no one standard to rule them all, obviously. That then allows that better decision making and drives better capabilities. And so, circling back to the question, I'd say as a new person coming into the environment, you need to kind of have that global perspective on, how do we make sure that data works for everybody in pursuing right and moral causes, right? In the terms of national security environment. I think that's one thing I would recommend.
I want to make one quick clarification in terms of the point that I referenced with regard to Russia. What I was referring to was the Russian cognitive awareness of some of these Ukrainian counteroffensives,
I'm sorry.
not necessarily the Russian invasion on the first side, because that seems clear that that was a point of American intelligence success, but also born of satellite-driven intelligence.
I
And
misunderstood you.
no, no worries, no worries. But for anyone in the audience, that's an important sort of distinction. Um, David, the point that I made in terms of what to look for, so to speak, and then we're going to go to audience questions.
What to look for if you're new
If you're
to
coming
the
up, if you're coming up
coming up, yeah,
and you're seeing this landscape change in front of your eyes, and you think, how can I
definitely.
possibly get ahead of the curve here to make myself valuable?
Yeah, I would say one, don't think that you have to get ahead of the curve and then you'll be able to sit there nicely for a career. You're always on the curve. You'll be riding that curve your entire career. So, this is about continuous learning, always learning how to create new value, new information product that can support whatever your customer base is, and be curious about the world and learn from it. I think the tools that AI, geospatially, large language models, whatever they are, they're going to help us ask better questions and continue to create more value to make people's lives better and create economic value for improving society as a whole. So that will happen, and I think our private industry and companies will be very efficient at delivering that kind of value. So I'm not too worried about the standards of interoperability. I think the industry will work that out over time. Yeah.
Okay, great. Well, we've got 14 minutes left of this webinar, and this has been great so far. So I really appreciate all the rapid fire questions that we've had, or excuse me, rapid fire answers that you've had. I'd like to go to our first question, which is from James Cox, and I'll just be sort of reading what he wrote in the chat here. As he said, I recognize the maturing influence and quality of so-called geospatial intelligence. And then he says, I say, quote, so-called, because I've not heard here or elsewhere how the capability is anything more than geospatial information. And so where does the assessment of future probabilities to enable advantageous action happen to make it truly geospatial intelligence? who would like to answer this one? I'm not quite sure which one of you falls into the same into the right purview for this one.
I don't mind taking a quick stab.
Okay.
Since kind of, I asked myself and my team, my title's head of analytics and insights. What's the difference between an analytic and an insight? Is one of the things I often ask myself. And I think traditionally being able to identify or classify certain things is just really transforming data into other data, or data into maybe less data, a series of pixels in an image that might be distilled down to T72 tank, right? It's just the same way we ask, like, when a small child, an infant to a toddler says, that's a red ball. Is that intelligence? Well, oftentimes we say they're getting smarter. Oh, they know it's a ball, right? So I think that there's this continuum of intelligence. At present, I'd like to say that it's probably something more along the lines of moving from, we've detected, let's say, a series of objects or changes, to some correlation with what that may represent. An example of this might be a whole bunch of tanks are no longer parked in a garrison, but they're out on the range, or perhaps they're advancing to the border of Russia and nobody noticed. But which of those things, saying vehicles have moved here to here, and it's probably to do this, or because they're in this location, this is the activity happening, is to me where you're starting to get more towards an insight or intelligence versus information. But I am the commercial side of it. We have folks from actual intelligence related organizations. I'd love their take on what the difference truly is as well.
Gary, you want to take a step at that?
Yeah, I can try. I think JC did a great job, actually. But I would just say that I think your definition of intelligence is based on what the decision maker needs to make a decision, right? So they're looking for essential elements of information, numerous of them based on different data sets from different data sources, right? So when we're talking about geospatial intelligence in this case, especially with regards to AI, most data can be tagged spatially and temporally, so that by my definition makes most data geoint. But using those spatial temporal tags to identify patterns or anomalies presents the opportunity to give you some information that could be intelligence based on the problem that you're trying to solve. It's just a simple answer from my perspective.
Okay. Vic, I want to go on to the next one, and I'll go to you, David, for this next one, if this works for you. But Vikram Sarkel asks, how is NGA building systems to automatically run models on all that imagery automatically daily and not just limited to AOIs?
Well, I can't presume to tell you what NGA is doing and how they're doing it anymore. But the concept for Maven was to build models for a number of different geospatial intelligence problem sets and a number of different data types that can be used to solve those problems, and to train those models to get better over time with more labeled data, which is why they're about to spend $700 million on labeling data. One of the benefits I think that the government has in this regard is they're sitting on a corpus of 50, 60 years of imagery. So, millions and millions of images, many of which, were viewed by an analyst at one time and then put in a database and never seen again. And so now you have the opportunity to backwards label 50 years of information that will help your models predict into the future. And so I think the definition of intelligence is all about being better at predicting than you used to be. And so this is where I think NGAs is going with the labeling project.
All right, great. So the next question is from Alexander Rogers. He writes, with petabytes of data coming in, there needs to be more efficient way of processing that data than as just as raw image data or the like. For pattern of life modeling, are there more efficient ways of representing all that relevant important data points in order to optimize and reduce computational overhead. And I might add, actually, onto this question, questions of energy requirements and mere processing speeds, and sort of the growth of questions about doing some of this processing actually in situ in space, or at least in orbit, which is also space. But let's go to JC on this one to take an initial stab, if you like, or otherwise we can on to someone else.
Yeah, I do think, all of machine learning is rapidly driving just massive increases in kind of compute. And I heard about an AI center that XAI is building in Memphis that's like $1 billion compute cluster, right? I think it's twice the performance of the world's fastest supercomputer. But I also think that moving the processing paradigms to what one of the panelists mentioned, I apologize, Carrie or Dave, I forget which one said it, to not necessarily I need the image, but I need the insight, is also going to drive how we compute it. And so I think there are some things on some sensors that may move towards more an on-orbit processing capability, but I think of that probably as a triage function. Like if I have a moderate signal in an image that might say something's occurring, that might enable me to more quickly downlink the high resolution, Maxar data, or, or like one of our partners, Umbra, their SAR content for analysis in a prioritization system than to say we're going to figure out how to power and cool, massive compute clusters in space. I do believe we will one day have like, AWS, Leo region instead of US East 1 or Gov 1 or whatever. But I think it's going to start with prioritization of where you process what in what order to get that kind of key insight to the key user decision maker. And it won't just be like process every image every day all the time, because that'd be prohibitively expensive, given that 1.7 or 9 petabytes I referred to earlier of data just coming down a day.
Hmm. I want to do something I usually don't do now, and that is go to someone who's already asked a question again, because James Cox is just killing it here in terms of his questions. So kudos to you, James, if you're listening here. I love this question. He asks, for all the geospatial intelligence capability it can do regarding life and phenomena on Earth, is there an equivalent, or perhaps will there be an equivalent, to space spatial intelligence function that can do the same thing in the space domain? Geospatial intelligence enables the fight in maritime, land, and air domains. Can space spatial intelligence support the fight in the space domain? And I think that's interesting for a couple reasons, if I might editorialize it for a moment. So one is just sort of the influence of increased sort of military focus in space, not least of which being Space Force. But also it sort of speaks to this nature of this frontiersmanship or frontier womanship as well, in terms of what we're looking at. And as we start to talk about the construct of cislunar development, or start to hear terms like the lunar economy, and you have all of these different plans, particularly as this sort of new administration comes in place with what seems to be an increased focus on Mars. What does that look like in terms of that space spatial intelligence function as we start to press out? Is it just merely continuation of what we're doing at the same sort of exponential growth rate, or is it something decidedly different?
I'll go ahead and jump on that if you don't mind. About
Yeah.
5 years ago, I co-led a study that was basically how will NGA apply the geospatial intelligence discipline to the space domain going forward. And so, you quickly can draw parallels with the other domains, air, land, sea. There's terrain in space. It's usually gravity and maybe debris clouds and other things. Will be borders, right? There will be areas of the moon and cislunar orbits and other things that are claimed by nation states. So, and there will be problems of maneuver, problems of navigation, all these things that GeoInt solves today on the Earth, are problems that will exist or do exist in the space domain. and will need to be solved again. So where are the resources? How do you efficiently extract them and use them? Where should there be insurance claims? Since JC worked in insurance, right? There will be an insurance claim in space at some point. So if there hasn't been one already. So I do think that these are good questions to ask, and there's a lot of value from sort of this geospatial world to the space domain.
Gary, I'd love you to take that question too.
Yeah, I'm not sure I have a lot more to add to what Dave said. I think there has been application of the similar capability for quite some time now, and going back within NGA, but also in the Air Force and then the Space Force. And so I think what we're seeing is a maturing of that as now there's greater focus through the Space Force.
Right. All right, so we have just about 2.5 minutes left, 2 minutes left of this webinar. And I'd like just to kind of take this as an opportunity, first of all, to thank the three of you for coming on and being so forthright with your answers, but also to maybe give us a sort of a gut check moment. Is there anything that we haven't discussed here that maybe is hanging out there that you'd like to kind of to incorporate, whether it's in terms of shifts or even just sort of innovations that you're paying attention to that are soon to be coming online? JC, I'd like maybe to go to you first because of the commercial side of this.
Yeah, thanks. And thanks for the opportunity to be here today. I mean, I do think it's interesting, especially the last question James Cox said. I mean, Maxar does have a near Earth imaging product, which is not designed to help you understand the surface of the planet, but what's happening in the space around the planet. And I recall talking with one of my counterparts about wouldn't it be cool to use this beyond the Earth to map Mars or the Moon or other places. And so I think that is where a lot of these technologies over the years will land. I would say the thing, at least from my personal perspective, I'll not speak corporately, is thus far we only have one Earth, and I do think that really kind of leveraging as much of our technology to improve it and those who live on it is probably closest to my heart. But that all these things are going to enable a lot of interesting other use cases as we as a species and civilization attempt to get beyond it. So that's my closing note.
That's great. David, I'm going to give you the last word here because we've got about a minute left.
Okay, well, I'll mention the human quality data labeling challenge is massive, right? If you could think of all the data that's coming down and all the models that need to be trained and retrained and forever trained, there aren't enough humans to do it. $700 million program isn't enough to do it. So we need new technology innovations. We need more resources. One of those innovations I've seen is the ability of AI to create synthetic training data. If you can create synthetic scenes and populate those scenes from all geometries and train them up in a day, you have the opportunity to go quickly. And we've talked about how speed is the central theme of this hour. So I'll end it there.
Well, that is a good place to end it. I want to thank the three of you. I want to thank everyone in attendance and some of the excellent questions that came down the pike. We're trying to do these webinar forums at least twice a month. We're getting some really good topics from both our folks, but also just sort of there just seems to be a lot more conversation in terms of what could be and what is and where this is going, and just keeping pace with all of it is can be tricky. And so I really appreciate the three of you coming on to kind of help guide us and be a bit of a lighthouse in this whole process. This webinar was geospatial intelligence and data labeling for AI, but perhaps it should have been the need for speed. I just want to thank all of you for coming, and that wraps it up. Thanks so much.